In terms of scaling EIGRP, when you look at EIGRP as a protocol, it is able to tolerate arbitrary topologies better than other routing protocols. Now, what we mean by that is that EIGRP can handle a topology that is not designed in a hierarchical fashion. But that's not to say that we don't want it to be designed in a hierarchical fashion. So in fact, the recommendation is that we do use a structured hierarchical approach when we design our EIGRP networks. Now, in a small network, this is not very important, but it does become more important as the network size increases. So the bigger the network, the more important it is that we have a structured network, a hierarchical network. Now, what are the benefits to this? Well, again, it comes with the scalability concept. See, being able to scale EIGRP depends on the topology. So the more structured our topology is, the easier it is to scale. And the benefits that come from that are revolving around how quickly we can converge and make adjustments when something changes in the topology. So it would have to do with things like, well, route summarization and route filtering. See, these are things that help us to scale EIGRP. It's not easy to do route summarization if we don't have a hierarchical network. It's not easy to do route filtering if we don't have a hierarchical network. So these are reasons why it's important for us to use a structured approach to our EIGRP designs. Now, another benefit to using the structured hierarchical approach is that it helps us to limit the scope of our queries when there's no feasible successor. Now, what are we talking about? Well, let's just assume that we have a couple of routers, and let's just say that these routers that we are talking about here are exchanging routes between one another. So we'll just put a couple of routers here, and we're going to connect them together. We'll go ahead and make a couple of connections. Let's go ahead and do that. So we've got a connection between these two routers, and a connection between these two routers. And then we have a network sitting over here off to the side, and we're going to say that that's the 10 network, or whatever network it is that we're going to be concerned with in terms of making sure that we can reach, right? So let's go ahead and say this is the 10.0.0.0 network. Now, router A here is going to obviously pass that routing information over to router B. Router B will then go ahead and pass that along to router C using the standard EIGRP routing methods, right? Now, if for some reason A loses this network, now the process is first we look to see if we have a feasible successor. So remember, the concept with EIGRP is that if we have a feasible successor in our topology table, then we go ahead and use it immediately when the successor route is no longer reachable. But since we don't have a feasible successor in this example, router A is going to send a query over to router B. Now, router B is not going to reply back to A yet, but rather he's going to query router C. Now, he's waiting to hear back from router C, and router A is waiting to hear back from B. So when C replies back and says, I don't have a way to get there, and B replies back and says, I don't have a way to get there, well, now we're converged. But until then, we're not converged. A is actively looking for a route. Now, the larger the network, the larger the scope of our EIGRP queries, the longer it takes to converge in our networks.